have the Loonies. We still have the Loonies. There are some Loonies who believe that the moon spins. And, I've gone with this already several times now. I thought they'd get it by now, but no, some people are fighting it. They say, no, the moon spins, Bill, you got it wrong. Okay, so here's one fellow, and he says the following. It says, the moon is tidal locked to the earth. This is synchronous rotation, not spinning. Rotation? Rotation is an ambiguous word. I already mentioned that in the past, but this guy has, he's a little solid in the head, made of a single piece, or maybe nothing between the ears, whichever way you want to see it. Rotation is an ambiguous word. It could mean orbit, or it could mean spin. And so when you use rotation, all you're doing is obfuscating the issue, because you're not clarifying whether it's orbiting or spinning. So you should not use the word rotation or any synonym. We should leave it to two words, spin and orbit. Those are clear cut. People more or less distinguish a spin from an orbit. Okay, so anyone using rotation is just trying to obfuscate the conversation so that he doesn't lose his religion. That's what it's all about. And he says spin doesn't require an axis and is fast motion. The moon does one rotation. So on its own imaginary axis. So what's the difference between rotation and spin? We'll never find out from this fellow for sure. Okay, he says one is fast, the other one is slow. I guess that's all it is. But they're both around the axis, spinning around the axis, whether it's rotating, revolving, orbiting. It's all the same to him. So we need to distinguish these words. And so that's one fellow. Here's another, not one, but two other fellows, and they say the following. I've watched 3 videos about spin, and I never seem to hear why the rod pounded through the earth is moving, but the rod in the moon is static. And another fellow says something similar. Says, why is the earth axis still? Neither axis is fixed. I'm wondering, why are these poor people in science, why do they come to science sites? I mean, these people should be, at the monastery, cleaning latrines, for the church or something, or maybe lighting candles. I don't know what all these altar boys do out there. But these people don't belong in science. They don't have the mental capacity to be in science. Okay? Let's see if we can clarify for all these poor folks that were not blessed by their mothers, and they got the brain that, maybe the scarecrow left behind. Okay? So let's start at square one. Let's see if we can go slowly. And I'm sorry for all those people who do understand. I just got to go slowly for the people who don't understand, the little students who fall back in the class, right? Okay, let's see if we can bring them up to speed. Okay, so let's start at square one. Does God exist? That's the million-dollar question. Well, the guy might say, well, yeah, God exists. Okay, how did you arrive at that conclusion? Why do you believe that God exists? The guy said, well, one day I was puking my guts out in the bathroom, and I prayed for salvation, and Jesus Christ came and talked to me, and oh my God. Sorry, bud, that's not how we do it in science, okay? We don't do it like the atheists do it. We don't do it like the agnostics do it. We don't do it like the theists do it. We do it the scientific way. And that goes against atheists, theists, and agnostics, all 3 of them. Okay, all those are unscientific. Okay, how do we do it in science? Well, the way we do it in science is we define the word exist. Otherwise, we have no idea what we're talking about when we say God exists or God doesn't exist, or maybe God exists, so I don't know if God exists, I don't know if I can prove him. You have to define the key words that make or break your argument. So the first word you have to define is the word that no one has defined in the last 10,000 years, which is the word exist. You need to know what the word exist means before you can say God exists or God doesn't exist. I hope that's clear to someone out there, okay? You have to define the word exist. No one has defined the word exist ever. We still don't have a definition for the word exist. What we have in the dictionary are synonyms. What is it? Being, living, reality, real. Those are all synonyms. We can't use those synonyms. You can't define a word, scientific word, using synonyms or antonyms. Okay? So we define it how? Physical presence. Physical stands for object. Presence stands for location. What does exist mean? An object that has location. Okay, now we know what it means. Now we can use that word to make our case. Now you can understand what we're talking about because we have defined the word exist as object that has location. Okay, and so now a person might say, well, we have to define the word God because we need to know what the word God means. The answer is no. We do not define the word God. I hope that's clear. It's a big no. We don't define the word God. First, we have to determine whether God is an object or a concept. Concepts we define. Objects we don't define. We point to objects so the ET, the Klingon, understands what we are referring to when we mention the object called God. So you point, say table, you point and you say dog, you point and you say tree, and you point and say God, if that's what God is. If God is a concept, love, intelligence, energy, then you define it. Okay? So we don't define God. First, we have to determine whether God is an object or a concept. Then, if it's a concept, we define. Okay? Okay, so moving on here. Here we have God. Is God an object or a concept? Concepts, we define. And objects, we point to, just like God is doing right there. Okay? So that's the first thing we have to determine. Okay? So I hope that's clear. People can always ask questions later on. Okay? And we'll see if they have anything to say about it. So what did we do here? First, we defined the keywords because we're going to make a case. We want the other person to understand what we're saying. So we have to define, in this case, this example, the word exist in order to talk about whether God exists or not. Okay, is that clear? I hope so. Okay, so now let's go on with spin. Is Jupiter spinning? And someone might say, yeah, it looks like it's spinning. How did you come to that conclusion? You might say, well, I see the red spot going around and around periodically. Looks like it's spinning. And I say, what spot? I don't see any spot. The spot, the big red spot, you know, that Jupiter has, it's going around and around and around. Well, I'm sorry, I forgot to tell you. I was born blind. I don't see anything. I'm blind. I'm also quadriplegic. I can't use my hands to feel the surface to find out if it's spinning or not. So what do we do now? Well, maybe we do what we did with the word exist. We have to define the word spin objectively so that we know what we're talking about. And that's what this individual who came 3 times and hasn't figured out what this is about. It's about defining the word spin. That's what it's about. So why does he ask this stupid question like why? And the other fellow the same thing. This is not a why question. Where did they get this why? It means they're not even paying attention. They don't even know what's going on here. And the guy came 3 times. Tells you a lot about, some of these people. Now we're trying to define the word spin so that we know whether we can use it. That way we can use it consistently and say the moon spins or the moon doesn't spin. Jupiter spins, Jupiter doesn't spin. The top spins, the top doesn't spin. We can talk intelligently because we have a definition. But it turns out in 10,000 years, not a single mathematician defined the word spin. And that should not surprise you because spin is a word that belongs exclusively to physics. Mathematicians don't know anything or don't understand anything about physics, so they never define words for physics, they define words for mathematics. Okay, that's the problem. But then they extrapolate or attempted to extrapolate these words of mathematics into physics. That's what's happened, okay? Okay, so the first thing we want to do is eliminate, again, synonyms and antonyms. So this other fellow who used the word rotation, or rotate, okay, he's trying to use synonyms because he's trying to get away with murder. And that's what happens with all people who are afraid to lose their religion. So they use these ambiguous words like, oh, it's rotating, but it's not spinning. Well, what did you mean by that? What do you mean by rotate? Does it mean spin? Does it mean orbit? Does it mean any of those, gyrate to circle, around to spiral? What are we talking about? So the guy uses ambiguous words on purpose because he wants to obfuscate the situation, the discussion, so that he can get away with murder. And in science, we can't allow him to do that. So what we do is, the first thing we do is do this. We eliminate all synonyms. And we leave the words that allow us to talk clearly. Okay? So we're going to talk about spin and orbit. We don't need orbit because we're not going to be talking about orbit really, but I just want to distinguish these 2 notions. One is you orbit like the Earth orbits around the sun. That's one thing. That's not what we're going to talk about. We're going to talk about spin. Okay? And the question is, what does spin mean? Right now we have this to turn around an axis. This is the notion that people have out there. This is condensed version, okay? You might find other words in there, but essentially this is it, to turn around an axis. What does that mean? And the reason I ask what does it mean is the question is whether to turn around an axis means that the axis itself is turning or not. And the reason no mathematicians ever discovered this is they use a one-dimensional axis. And the problem there is that, there is no such thing as a one-dimensional axis. So how did all this start? Well, it started with a religion known as geometry. In fact, it's not a religion. It's strictly irrational. Geometry is an attempt to merge the language of mathematics with the discipline of physics. It's the first attempt by humans to merge these two, you can call them disciplines, even though mathematics is not a discipline, it's a language. That's all it is. It's like trying to unite, hieroglyphics with physics. Okay? Mathematics is a language. And the language was set up wrong when they attempted to incorporate that language into physics. And the first attempt was geometry, and they screwed it up completely, and they could have screwed it up worse. So we have an irrational, you can call it discipline now, known as geometry, which has rotten foundations to the core. So let's go through that real quick so that we understand what the problem is from the roots, okay? Here's the problem with geometry, okay? We have the 0D point. What is a 0D point? Euclid said no part, meaning or interpreted or translated as 0D, no dimensions, dimensionless. And they represent it with a two-dimensional or three-dimensional dot. They put a little smudge, okay, on there, and they said, that's the point. What do you have objectively in front of you? Well, you have a 2D or 3D dot. And so you look at that and say, okay, that's a dot. But that's not zero-dimensional. It looks like it's two-dimensional, maybe three-dimensional, but certainly not zero-dimensional. But it gets worse because that dot represents a non-dimensional concept known as location or position, as mathematicians call it. So let's see if we get this right. We have a zero-dimensional point represented by a two-dimensional or three-dimensional dot that actually represents a non-dimensional concept known as location. Well, that makes a lot of sense. And keep in mind, geometry is founded on the point. That's the first thing that Euclid put in his book, Elements, right? The dot, the point, the location. Okay, which is the foundation of geometry. And to this day, by the way, okay, that's how it's taught, and that's what you'll find all over the planet. Okay, so now we go to the 1D line. What is the 1D line? Well, it's a row of points, maybe. Or maybe it's a trajectory of one point, of one location, because that's what a point is. Point is a location. So now we have something very, very scary, which is the movement of a location. Okay, so it could be either a row of locations, maybe a row of apples occupying those locations, those positions, or maybe it's one position, one location that is moving, tracing an itinerary, and they call that verb a line. They represent it with a what? A two-dimensional plane, elongated plane, and they call that a line. So we have a two-dimensional elongated rectangle called line that represents either a row of locations or one location that is moving from A to B. Okay? And what are those locations? Zero-dimensional or non-dimensional locations. You're following me? The whole thing is rotten to the core. The foundations of geometry are irrational. Okay? Now, where do we continue with this? Well, we have the imaginary 1D axis. What is that? It's a 1D line. What was a line? A series of locations, or maybe a row of locations, a row of apples, or the movement of an apple from A to B. I don't know which. Okay, you can take either one. Okay, but it's a one-dimensional line. What's a one-dimensional line? What's a one-dimensional axis? Well, it's an imaginary one-dimensional axis is unimaginable. You cannot imagine a one-dimensional anything. And people say, well, I can, Bill. You can because you're not intelligent. You can't figure this out. But I can. I can imagine a one-dimensional line, a one-dimensional axis. Well, if you're so smart, why don't you put it out here so that we can all see what's in your mind? I want to see it on paper, or maybe bring the one-dimensional thingy you've got in your mind to the conference and show us. And yeah, you can't put the one-dimensional out here because you cannot even imagine it there. Because if you close your eyes and visualize the one-dimensional, whatever you've got in your tiny brain, you will notice that it's at least two-dimensional. Otherwise, you cannot imagine it, meaning that you can make an image of that, even in your brain. And if you think that's hard, try the zero-dimensional dot, the zero-dimensional point, the non-dimensional location. See if you can imagine that. What are you going to imagine for a zero-dimensional or non-dimensional nothing? And that's what the line is made of. The 1D line is made of zero-dimensional locations. So it's all rotten to the core. You cannot imagine 0D, 1D, or 4D or beyond. You can only imagine, make an image of, picture, pictorial, 2D and 3D. That's all you can, that's the best you can do. You can't do 0, 1, or 4 and above. Okay? And so what's the problem? Well, the mathematicians never figured out because they're using the one-dimensional line, the one-dimensional axis, right? And what they're looking at, they don't even care about the one-dimensional axis or line. They just care about the distance from that reference point, that frame of reference, to the edge of the thing that's supposedly spinning. So imagine a ball, and you're looking at the location at the edge of the ball, at the surface of the ball, with respect to a location along the so-called one-dimensional axis. They get rid of the axis. They don't need a little line. They don't need that little strip. That's there only for pictorial purposes. They're only going to use the distance, the separation, actually the distance traveled, because they're only concerned about meters, feet, inches, whatever unit they use. So they're just going to take and say, well, did the distance traveled change? If it did, then it's spinning. But see, they're only looking at numbers. They're not looking at physics. They're not looking at the physical thing to find out if the thing is spinning or not. That's why when they say, well, does the moon spin? They say, well, it does spin. Why? Well, because it's rotating around its one-dimensional imaginary axis. How can it rotate, or how can you use a reference whatsoever, the 1D axis? How can you use that if it's not something physical? And the issue there is that you can imagine a three-dimensional axis turning, like, that thin barber's pole. You can say, well, that's spinning, you can imagine that spinning, right? Because you can picture it. You can imagine it spinning because you can make a picture of it in your mind. You can watch the movie. You can't do that with a one-dimensional axis. And because you can't do it with a one-dimensional axis, the mathematicians never figured out whether the axis was spinning as well. Why? Because they cannot imagine a one-dimensional axis spinning, because they cannot even imagine a one-dimensional axis to begin with. You can't use the one-dimensional axis to talk about spin. Spin belongs to physics. One-dimensional belongs to the religion of mathematics, to mathematical physics. Not even to math, because math has no use for the one-dimensional anything. Math uses distance traveled. That's what they're concerned about. Okay, so this is where the problem starts, and it ends there. Okay, so what's the story here? Well, here we have a ball orbiting, there it is, a two-dimensional, okay? Barber's pole, you could say maybe a axis, but a two-dimensional one. So that you can take one edge or the other edge of that line. That is a line there, two-dimensional. Okay, that's what a line is, two-dimensional, remember? You have to be able to picture it. No such thing as a one-dimensional line, especially now for the purposes of physics. At best, you can say three-dimensional. But you can maybe mimic it with a two-dimensional and still make your case, like I'm going to do now. You can say that ball, which represents just the location on the edge of a sphere, for example, could be a cube, could be anything that's spinning, right? If that location, which I'm representing with a ball here, okay, I'm going to do that, just play a mathematics on you, right? I'm going to use a ball to represent the location. It's just you could be an atom, could be an electron, whatever you want, on the surface of a physical entity. So you can say it's an atom. Yeah, you can picture it as a ball, whatever you want. It doesn't matter, because we're concerned about defining the word spin. That's what we're doing here. For those people who've been here 3 times and haven't figured it out yet, we're trying to define the word spin. That's what this is all about. No why. Please don't ask why. Stupid questions like why. This is defining the word spin. Okay, so is the ball spinning? Well, if it's changing its distance with respect to each of those edges of that two-dimensional line, then it's spinning. If it doesn't change the location with it, because the pole, two-dimensional pole, is spinning at the same rate as the ball, then it's not spinning. Okay, do we have that? So we're going to be defining that. So here, let me show you another picture of this so that you get an idea where I'm going with all this. Here you have the moon. Is the moon spinning? And you would say, well, no, it doesn't look like it's spinning to me, because staring at it, it certainly doesn't look like what a top would look like that's spinning. And that's just the point. If you're moving together with the moon around the earth and always staring at the same mountain, same valley or whatever, is the moon spinning according to your perspective? And you say, well, no, it's not spinning according to my perspective, which again shows that subjectivity Seeing, touching has nothing to do with what we're talking about here. It's got nothing to do with the definition of the word spin. You cannot define the word spin using see or touch. Okay, we're blind, we're quadriplegic, we can't touch, we can't see. So whenever you have problems, close your eyes and you'll be safe. Work with the definition. We need to know what the definition of the word spin means, or what it is, what it represents. Okay, so let's look at the definition of the word spin. Give me a second here. And here it is. That's why we need to define the word spin so that we can talk intelligently. And there you have the definition of the word spin. Surface changes distance with respect to a 3D axis. Okay, so you have atoms on a 3D. Now you can talk about imaginary axis because you're going to run an imaginary axis through the Earth or through the moon. And the only issue here is, does that axis spin together with a surface or not? That's the only issue. Okay, if it does, if it spins together with a surface, the thing is not spinning. Only if it's standing still and the surface changes its location with respect to each atom of that three-dimensional axis do we call it spin. That's the definition in physics of the word spin. Okay, do we have that much? Okay, and so yeah, you can see that the moon is not spinning because the barber's pole is spinning together with the surface at the same rate. And you would see always the same face if you were spinning. If you were moving around the Earth together with the moon, you would always see the same face. So you can't say that it's spinning. And you can't talk about rotating. We don't use that word. Remember, it's a four-letter word. We don't use that. It's only people who try to defend their religion that will use the word rotate or some other word similar to that. No, we say if it changes the distance, the separation, okay, with respect to the axis, then it's spinning. If it doesn't change its distance, its separation, then it's not spinning. That's the definition. You might say, well, I don't like your definition, Bill. It destroys my religion. You're raping my virgin. Okay, so this is the way we do it in science. Okay, just for those of you who are interested in science, this is the way we do it. You must define the word. You got to get in the ring and fight for your definition. Your solution is easy. Come up with a definition that is for a better mousetrap. You can't use tradition. You can say, we've always done it like this. This is what we've always used. You can't use democracy. All the mathematicians voted for my definition. And you can't use authority. Well, that's what I found in the dictionary. Now, there's not a single definition in the dictionary that is scientific. Okay, so don't use the dictionary ever, because all the definitions are unscientific. They are ordinary speech. You have to come up with your own definition and fight for it in the Colosseum. You got to get your sword, your shield, and defend your definition. It's the way it works in science. Okay. Hopefully we got that straightened out as well. So you don't like my definition? No problem. Come up with a better mousetrap and be able to defend it. I'll be glad to tear it to pieces. Okay. Okay, and so here's the corollary to all that, and it comes from this gentleman. His name was Thomas Kuhn, and he's famous for inventing the term or the notion of paradigm shift. And this was his notion. Okay, he said paradigm shift. It's scientific revolutions alter the very definition of science itself. So we redefine science. Yeah, 17th century so-called scientific revolution defined the notion of science that they had since the days of the Greeks. And they screwed it up because they said science is math and experiment. Descriptions. And we're saying something different today. We're saying, no, science is not description. Science is explanation. And that's something totally new. They've never done that. They've never done explanations. Do we have an explanation today of how a magnet attracts another? Have you ever found one that you can sink your teeth into and say, oh, I know how a magnet attracts another? Do we have an explanation of how gravity works? Why, a pencil, right, falls down and not to the sky? Do you have a rational explanation for that? Or are you still using warped space-time, a concept? So no, we don't have explanations emanating from the establishment. Every time you push them for an explanation, they say, well, we don't know. We're still studying. Someday we'll figure it out. So they don't have an explanation for anything. All they have are descriptions. Why? Because mathematics can only describe. They equated math with science. We are doing a paradigm shift and saying science is not descriptions. Science is explanations.